around a month and a half ago, I started building a game using the Rust programming language. I wanted to learn Rust. That was my main goal in the project. So I want to explain how I did that. If you're looking for a video that wants to tell you the best way to make a game, this is not the video. I spent a long time making a silly little kind of 2D MMO style top-down tile-based game. If I was to use Unity or RPG Builder or Game Maker, one of those other engines, then I would have probably been able to do what I did in 3 days, 4 days, a week. But that building a game wasn't really my primary mission. My primary mission was to build something that was 100% open source. Anyone should be able to clone the GitHub account and build from source. So they shouldn't need to download RPG Maker, Game Maker, Unity, any of these closed source packages to be able to take my game, fork it, and make changes to it. And goal number 2 was to learn the Rust programming language. So everything I've done so far is all in Rust. And the reason why I chose to do it that way is because A, I want to build something that's completely open source. B, I think the Rust is an incredible ecosystem for building games. People that don't know about Rust, it's a systems programming language. So what that means is systems programming languages are basically C, C++, Rust, and Golang. So these are compiled languages that ideally don't need a garbage collector. Golang uses a garbage collector, but some people still throw it into the systems programming language bin. And these are languages that we use to build operating systems. So the Linux kernel, C++, it is primarily developed in C++. So that's and I'm a systems programming language person, so the pick was perfect. And there's tons of game development happening in Rust. Like there's communities that are excited about this thing because Unity and a lot of the other game engines use C++. So people are thinking, okay, well, if we have something better than C++, aka Rust, then why don't we build games in it? Which is a brilliant idea in my opinion. And before I basically kick off how I did this thing, I want a huge shout out to 2 communities. One is the Rust community, specifically the hash Rust on Freenode. There's tremendous support there. If you have a question, you can just ask it, and you can be a flaming beginner, and everyone is just so brilliantly nice to you. And 2 is the Amethyst team, which I'll get into later, and the Amethyst Discord. Again, everyone's extremely welcoming, which makes it easy for beginners. And before I started this project, I knew nothing about Rust, I knew nothing about game development, I knew nothing about Amethyst, which is the game engine that I chose, which is developed in Rust. I got to a thing that I was pretty frankly happy with, a cool little kind of top-down game. I'm going to be taking a bit of a break from it in the next couple of weeks just because I am starting a new job. But I do plan on continuing to work on it for indefinitely. So before I get started, I want to explain what I actually built. I'm recording, right? Good. So Cargo is Rust's package manager. Oh wow, it has to build. Okay, that's going to take some time. So Cargo is Rust's package manager / build system / kind of everything you need to use. So in order to build my game, all you need is you need to install Rust on your machine, and then you just clone the repository, and then you just type in cargo run release -- release, and it'll just run. You don't need anything else. So that was kind of something that I was pretty excited about. And another thing is you can actually, Rust rolls all the dependencies into the binary type thing. So right now my image is 3 megabytes, and if you can just take that and put it on any machine and just run the binary, if it's a Linux machine. My game's cross-platform, so Windows, Linux, Mac. But I mean, if you compile with whatever architecture and operating system, you can just take that binary and run it, which is pretty cool. So this is just building right now. So this is the game. It's not much, and but I did spend about a month and a half building it. And as I said, if I was to build this in some other engine, it would have been way faster. But game development wasn't my primary mission. So I guess there's three things that, I guess two or three, we'll see how many I start spewing out, components to what I built and kind of how the implementation. So as I said, the programming language is Rust. The engine is called Amethyst, which is, I would say, a medium heavyweight engine. It's definitely not complete yet, but it's very full featured. It has rendering, it has sound, it has some networking stuff, which I'll get into later. What else does it have? You can see right here. Yeah, I mean, tons of stuff. It's like they call it ECS, which is like, they call it a data-driven engine, which was kind of annoying to me because data-driven is kind of like an interesting term. But then I actually got into it. I'm like, okay, now I understand what data-driven means. So I'll talk about that later. Yeah, it just works. It works really well. It takes a long time, I would say, like a week or two, working on it. A week every day, reading it and going through the documentation to figure out like what's actually going on. And it was, if you're not used to game development, it might take even longer. Like, it definitely took me a while to get up to speed on it. But once you get going, it's you're like, okay, well, this is why they did it this way. Yeah, so I guess I'll just do a quick overview. In my game, you got a little guy, and you can walk around, and it animates. You can. So right now, this is you have to put my name on top, and this is running on an AWS instance. So this is like an MMO style. So if I do let's change names, cargo run, release client. I can run this, so I can see both of my characters have been instantiated, and it syncs across. So you could do this off of, it doesn't have to be on a local machine, like it will sync up. Yeah, that's pretty much it. There's a couple other things. There's like a combat mechanic, and I've made it so you can't walk through walls, which took like a while. Yeah, anyways, it's not much, but I'm gonna keep working on it, and hopefully it'll get better. Yeah, so I want to explain kind of how this thing works. So Amethyst uses something called an ECS based design, which stands for Entity Component System, and that's the kind of the core of how those three things are how the engine works and how your game works. So, because it takes a while to kind of figure that out. So right here, these trusty pieces of paper taped to my wall. I'm not actually going to take that off. It's too taped to the wall. So an entity is one thing. So say like I'll give an example. So a player might be an entity. In my game, a player is an entity. Let me draw that again. And entities have components associated with them. And a component is it's just a data construct. So in my game, player has the sprite component attached to it, which is the actual image. So I'll get to that a bit later. It has a transform component attached to it, which is the image's location on the screen, and it has an actual player object associated with it, which has a bunch of information about the player, health and items and stuff like that. And systems, which is the S in ECS, entity component systems, is how the game operates on entities and components. So, for instance, I might have. Why don't we look at some code? So here, so this is a system, and I've called it the animation system, the simple animation system. So this is how the little guy like visually walks. And this takes a little while to get used to, but basically in the Rust programming language you can, this is implementing the system trait on simple animation system, and inside there's a function called run, which just runs every game loop. And Amethyst will run systems in parallel if the entities and components aren't being like destroyed at the same time, like same parallel rules apply. So inside of this system, these are my components that I'm bringing into the system: sprite render, simple animation, player component, transform, and entities, so that you can actually get the entities of the associated components, and time. So this is actually a resource, which I'll get to a bit later. So these four things are the components, and this is where the magic actually happens here, which is kind of interesting. So this runs every loop, and this is going to do, so this is basically like an AND gate. So for any entity that has a sprite render, an animation, a player component, and a transform, take that specific entity, so it'll take the specific components of one entity and run this for loop. So you're operating on all entities that have those four components I've listed, which is kind of the meat and bread of this ECS based thing. So if you say you have like a bomb that goes off, you would loop through all entities that have component player, transform, maybe player and transform, and if their transform is in a certain radius of like bomb, then you would subtract some health or something. And that's a way to modify everything in the game kind of all at the same time, rather than individually going through, oh well, is this player there, is this player there, and you just data driven kind of means that the existence of data means something in and of itself. So when your player walks, there's another system that just attaches an animation component. So if nobody's walking, nobody has an animation component, this for loop never gets executed. So attaching an animation component is indicated that, okay, this system should run and it should operate on players that have that component and make them walk. And once they've finished walking, just delete the component. And that's exactly what this does. So that's kind of, that's in my takeaway, that's kind of what data-driven means. That's what data-driven means in this context. Another thing I wanted to, okay, so that's kind of ECS-based design, which is a huge aspect of the Amethyst game engine. Rendering is pretty simple, so it's pretty simple because the engine makes it very simple. So let's make that floating. No, I don't want to do that. So since it's a 2D, Since it's a 2D game, it operates using sprites. So I chose 16 by 16 sprites. So basically, you build something called a sprite sheet. You can have several sprite sheets, or you can have one massive sprite sheet. It's up to you. And effectively, the engine will load this in. So I use a library called rstiled, and it loads it into this like huge vector of sprites. And when you want to draw that, you just create what's it called? Sprite. Sprite render. You just create a sprite render component. So you would create a player sprite render component, which is a handle to one of these sprites, and a transform, which will put the sprite in a certain spot, and then that's it. It's quite simple. There's some other I guess nuances on how to load in these sheets, but that's all in the source code. It's quite simple. And then if you want to say your guy changes direction, you just change that sprite render handle. You just load in, so you put in another value, and it just changes in the game, which makes things pretty straightforward. So this is my sprite sheet basically, and when I want to add more, I just append more to the bottom, which I don't know if it's necessarily the right way to do it. And the map is built in the exact same way. Well, actually, it's not built in the exact same way. It's totally different. So in here, I have file called map, and this is first. This is no, that's not what I want. This guy. So effectively, tile-based games, the maps are built up of layers. So on the bottom layer, I have some ground. It's not super consistent. I've kind of messed that up a little bit. And the next layer is like floors, so you can put stuff on top of that. And then items go after that, and then collision objects go on top of that, so things that you can't walk through. So I'll get to that a bit later, actually, because it's a little bit more complicated than that. And then other collision objects, and I call it TP, teleport objects, where if you stand on top, you might go to another room, which I haven't implemented yet, and then monsters on top. And this looks familiar. This is my sprite sheet. So this application is called Tiled. I want to give a shout out to the creator of Tiled as well, because it's an open source. It's just developed by one dude, I'm pretty sure. He seems to answer all the questions on the forum, so. So maps, the map format is called a TMX format. Tile sheet is called a TSX, and it's also like a PNG, it's just an image. So you load in the PNG, then you create a TSX file, which gives various traits to different things. So, for instance, I've given collision to this little rock thing here, so your guy can't walk through it. And then, so a TMX tells the engine where to place the little bits. And rstiled was that kind of bridge between loading in the TMX, decompressing it, and then piping that information into the engine, and basically just running a loop and saying, oh, here's this, place this here, place this here, place this here, place this here, and then it just draws the entire map. And it's quite performant, actually, like it loads very quickly. So that's how maps are created. It's pretty, like, it sounds very straightforward, but it actually took me a while to kind of glue all of these components together. Like, some things are, like the Amethyst engine, like I think the Y is switched or something, so when you first draw the map, like everything's all backwards. And if you load in your sprite sheet incorrectly, the whole thing just blows up because nothing's correct, like all the tiles are wrong. Yeah. So I guess that would be so ECS as far as learning. ECS was big. Rendering, like drawing these maps, placing the characters, making the characters move around, animations. That was also big. And then the biggest thing, the hardest thing for me, the biggest challenge was networking. Networking is huge. And reading about networking and getting into how people do this, like, I decided when building this that I am of the opinion that, like, first person shooters that handle a lot of simultaneous players, like Call of Duty online, are possibly the most sophisticated software ever created. Just because of the synchronization in such a short amount of time, low latency that's required. You know, like you have a server, and they don't just use one server, they have like 20 servers, and each server is for like a certain area of the map in Call of Duty or these shooters, because one server can't handle all of the whole map, especially if it's big. And they all link together to one master server, which manages all the player identities and everything. And when you're basically, like, your little guy is running around and you're sending all these actions to the server, and then you point your gun and there's some guy over there and you shoot, and the server has to calculate the vector of where you shoot and anticipate where the person is going to be, because the latency isn't it's not fast enough to say specifically where he is right now, because it doesn't matter where he is now, it matters where the guy's going to be in, like, once the whole latency round trip by the time you say shoot, and then the whole thing comes back. And then so, like, synchronization is huge, and even in my little, this, like, basic game, it was still a lot of work. So as far as networking, that was a big thing. And I wrote a blog post about networking a while back. I'll maybe link that in the description. But I think in the blog post I distilled networking to the task of synchronization of server to all the other clients. And what that means is you need to form consensus among all the clients. You need to say, this is what the game state is, this is where these players are, this is where their health is at, this is where this is what they're doing, and you need to make sure that all of the actions are legal. So when I, for instance, in my little game, so there's a wall here. So when I hit W, my client looks and says, oh, there's a wall there, I can't walk there. And the client doesn't send the walk move to the server. I'm not getting anything. If I sent that walk move anyways, so if I changed the code on the client and said, okay, you know what, send that walk move anyways to the server then needs to say, no, there's a wall there. It needs to check. And then it shouldn't update the rest of the clients with the position of that player. It shouldn't just let you do whatever you want. And the same goes for changing outfits. So, like, I should show this. So in my game, you can change outfits. Outfit nude. Woo, now my guy's nude. I also want to shout out to Lena. Lena Zimmerman for creating this tile set. She did all the art for this and released it under a license that allowed me to use it. And the same goes for outfits. So when I say I want to change an outfit, it's going to tell the server which outfit, but it needs to be correct. It can't just be some illegal thing and then send it. The server relays some crap back to the clients, and they all just blow up in segfault or something. Another thing was the transport layer. which was huge. So I ended up using TCP, but that's because in Amethyst network, the networking library, there's 3 options: UDP, TCP, and laminar. And the laminar implementation has a couple problems right now. So basically as I was saying earlier, Call of Duty, those guys use UDP. And the reason why is because TCP is a connection-driven protocol. So you have a client, a server, and the client connects to the server, and the server says, oh, the client's connected, and it manages that connection. Like the TCP as a protocol manages the connection. And it's also, TCP it'll deal with data packet drops. So if data drops, it'll retransmit. So and I'll get into why that's a bit of a problem for low latency games in a sec, but it'll ensure ordered. So if you send packet 1, 2, 3, 4, 5, the server is going to receive that in 1, 2, 3, 4, 5. It's not going to be like 2, 3, 4. It's going to be that order. And but the reason, so it's like, okay, great. So why don't we use TCP? Because it has issues with latency. If I'm the client and I connect, and then I send packet 1, 2, 3, 4, and packet 1 gets dropped, then it has to relay back to the client and say, oh, send packet 1 again, and then you send packet 1, and that round trip latency, because you can't get 2, 3, 4, 5 without 1. And you need to resend that because it guarantees ordering. So that round trip latency, it can end up taking like half a second, which just is not good enough for FPS games. So there's other things that people do to combat this. So for instance, the laminar implementation, which is meant for Amethyst, which is another library, uses UDP with a heartbeat packet. So you want a connection-driven protocol. The server should know when clients connect and disconnect, or else the server is going to maintain this client list and it's just going to grow forever, not knowing when clients connect. And you can't have a client like send a disconnect message, because what if I just like Control-Shift-Q this thing? It's just kills the process, and you can't just quickly send some disconnect. Like it's not good enough. So laminar is a UDP implementation that uses something called a heartbeat packet. So what that does is it just sends a packet every like whatever milliseconds, like 100 milliseconds or 10 milliseconds. And if the server doesn't receive the heartbeat packet, it just drops the connection. It makes UDP into this connection-driven version of UDP, which you need for games, and you get the latency. And there's other ways to combat this packet drop issue as well, where you stuff redundant data. So say you want to send packet 1, 2, 3, 4, 5, you just send redundant data with the packet. So you send packet 1, and then the next packet you send packet 1 and 2. So if you drop packet 1, you still have 1 and 2, and then the third packet you send packet 1, 2, 3, or some combination of this. So if you drop packets, at least you have redundant packets and you don't have to retransmit. And that redundant data doesn't really matter in the context of games, because most of the data you're sending is very small. You're sending like move north, which is like a byte. So you can have this redundant data. So the laminar implementation on Amethyst Network had a couple of issues, so I ended up switching to TCP. And it seems to be working fine, but once we get the laminar stuff figured out, I'll probably switch back to that, because it's the lowest latency and you can get lots of players playing simultaneously with low latency, and I think that'd be cool. Okay, so what have I talked about? Networking. I guess maybe more specific on how I actually did the synchronization of all this stuff. It works with kind of a command response broadcast style thing. So I have you create a package. The client will create a package, and it'll put command inside of there, an ID, and a socket address, which you can just leave as none. That's kind of used on the server side. And the command can be like connect, transfer map, insert player, action, where actions are another enumeration: move, rotate, attack, use item, change outfit, melee, update player, remove player. So the client will send an action to the server, a command to the server, sorry. Let's say it's an action. So I want to send action move, where the argument to that move is a direction. The server receives the move, unpacks it, it puts it in this vector, which just keeps getting appended to and bigger and bigger and bigger. And whatever system is responsible for processing that action. So on the server side, there's a system called PlayerMan, the player manager, and it'll basically just match action, and if that's a move, then it'll do the manage, and it'll check. It'll make sure that here it's calling map, and if it's allowed to move, then it'll say, okay, player walking, and then update the player, and then player clone, and the server then creates another pack. So this pack is a broadcast pack. That's why none is in the IP address field. So it's going to take all the clients in the client list and send that update player command with the player object inside of it, which has the new location, and it's going to send that to all of the clients. And then the clients are then going to do the exact same thing. So they have a player man system, which is responsible for, I'll show you. So this is the client-side player management system. So element command, if it's an update player command from the server, then look for all of this is what I was talking about earlier. Look for the transform, the player, the sprite renders, the tints, which I never talked about, but don't worry about it. And inside, if the player name is equal to the new player that you want to change, if change the translation, change the orientation, change the health points, and then insert that new player as a component into that entity, therefore updating it. And it just changes. Like, it's brilliant how this thing works. Like, it's so well thought out, and it's super scalable. So I can just arbitrarily change a player on the server, and and then make this pack, this update player pack, and then like dump that into this vector, the networking system, which is also a system. Well, this is the client side. I'll show you the server side networking system. I believe it's called TCP, yeah. So this says, so this is IO pop, so it takes elements from that vector that I was talking about. If they have an address, then send it to that address. If that's none, then just broadcast it for all addresses in self.clientlist.clone. Just blast out to everyone. And then all the clients will update that player. And since it's this kind of ECS design, all you do is change the transform components on the client side, and the guys just move there. So, I mean, it did take me a while to kind of figure out how the ECS design, how this thing basically worked, and how to best leverage it. Because when I started doing this, I'm like, okay, like I'm used to C++, like let's build objects. You start building objects, and I still have a lot of that. There's still a lot of like objective style of programming where there's a player object and this object and that object. But if I was to give any advice to anyone starting out, is the entity is the object itself, and the components are the members of the object. Alright, so that video was a bit longer than I wanted it to be. Hopefully it wasn't too boring. Hopefully maybe somebody learned something about it. I want to keep making videos like this, not as long, and maybe I'll get better at talking. Yeah, if you're interested in this type of stuff, like, subscribe. I'd love to hear from you. If you're interested in helping out, we are always looking for people to help out. It's an open source project, very inclusive. Like, as I said, all these communities that I've been working with have been super inclusive to all skill levels. Like, as I said, this is like my first game ever, my first Rust project, my first Amethyst project. Like, if you're a flaming beginner and think that, I can't do it, you you can. It takes a little bit of time, and it's super fun and rewarding. So anyways, if you're interested in helping out, drop a comment, send me an email, whatever. If you're interested in watching more of these videos, subscribe to the channel. Thanks.